Hi guys. So for today's lesson, we're going to be dealing with compass bearings. So you would have done a bit of this in the past, but I want to have a bit of a refresher today. Okay, so bearings. A lot of people typically have a lot of trouble with bearings. So a bearing is a direction from a specific point. So for example, north, south, east, west, they're all about just going in certain directions. They're types of bearings. Now we're going into a little bit more detail today. We've got true bearings. True bearings is a type of bearing which gives you a specific direction, which states the angle made with the northern direction. So it's very specific because you're dealing with a certain sort of angle that you make with the northern line, and it's always going to the right of that northern line. So here's an example of a true bearing. So the direction northeast. So we know that northeast is directly between north and east. So this green line here. So that's like in a northeastern direction. It has a true bearing of 0.45 degrees true, or T. There's always three digits with true bearings. So here we've got 0.45 degrees true, and that's our northeastern direction because it makes this 45-degree angle with the northern line. So it's all about looking and thinking, what is the angle between our direction and the northern line? It's always north for a true bearing. So, sorry guys. So example 2, the southwestern direction. So that's down here. We've got to think for this direction here, what's the angle made with this line here and the northern line going to the right? So it's this angle here, which equals 225. And the reason it's 225 is because this angle in here is 45 degrees. It's smack bang between south and west. And we need to go from this line all the way around. If there's a 45 degrees here, over here there's going to be 180 degrees. So 180 and 45 make your 225. So, yeah, you just got to remember, if you're going like perfectly between north and east, or east and south, or north and west, they're always going to be making some sort of 45-degree angle. Okay, so note the max bearing, if we go all the way around, make a full circle, it's going to be 360 degrees true. And that's going all the way around back to north. So therefore 0 degrees, which is just directly on north, is exactly the same as 360 degrees. So this is the max you can get. And when you get to this, it just goes straight back to 0. Both of these are north. Okay, here's another way of thinking about it. Here's a compass that shows all the true bearings going around. So you can see here, as you're going in different directions, as you go more and more around, the bearing gets bigger and bigger using these numbers here. So you can see here, if you want to go in a eastern direction, it's a bearing of 90 between the 80 and 100. And south is going to be between these two, it's going to be 180 degrees. And another way to think about that is the angle made with the northern line and the southern line is definitely a straight line. So therefore it's 180 degrees. West is definitely 270. And then eventually it gets it back around to 360, which is the north again. So you're pretty much picking one of these sorts of directions, and each direction can be described by using one of these sorts of numbers. So that's what a true bearing is. Okay, so moving on, there's a different type of bearing, a compass bearing, which you need to be aware of. So it's another type of bearing which states the angle made with the north or the south direction. So the true bearing is always the angle made with north. However, compass bearings can be the angle made with the north direction or the south direction. So, and it can be to the left or right of that north or south line. So let's have a look at an example. So northeast, it has a compass bearing of this, north 45 degrees east. So the idea is what sort of angle does this line make with the northern line, because it was north or south. So because this is up in the northern section, you're going to use the northern line. So it makes a 45-degree angle with the northern line. So therefore, that's the number that we use. And because on the eastern side, we also got to put east on the end. So it starts with using the north line, and then it's in between north and east, and it makes that 45-degree angle. EG2, southwest. So I look at this and I think 45-degree angle made with the southern line. And it's between south and west. So therefore your compass bearing is going to be south 45 degrees west. You want to say whether it's north or south first, and then whether it's east or west at the end. So hopefully these aren't too bad. You would have seen these in the past. Okay, so rules to remember. If using true bearings, so true bearings are definitely the sort of bearings that are most commonly used. Bearings which are in the opposite direction to each other. So a really important idea, because you have to deal with opposite directions a lot in a lot of questions. They're 180 degrees apart, there's opposite directions. So an example is, say, northwest and southeast. These two are in completely opposite directions. The northwest bearing is 315 and the southeast bearing is that. And I want you guys to notice that the difference between these two numbers, which are in opposite directions, the difference is 180 degrees. So if you know that two directions are opposite, you can find their value just using one, because then you can just add or subtract 180 to find the other one. Okay, let's do some example questions. So these take a lot of time. A lot of people struggle with the idea of converting these sorts of wordy problems into a nice diagram. But no, let's practice. So if Matt flies from Orange to Brisbane on a bearing of 37 degrees true for 760 kilometres, how far east does he travel? So that's maybe a little bit confusing to start with, but let's give it a shot. Let's get this diagram going. That's the first thing I want you to be able to do, start with a diagram. Okay, so first up, we're going from Orange to Brisbane. So I've literally made that sort of just brown line between these two, showing which way I'm going. Now, what I want to do, from your starting place, you want to draw in your north line, in particular your north line. We're going northeast, so I put the eastern line in as well. And the idea is we're going on a bearing of 37 degrees, so therefore that's the angle made with the northern line with true bearings. So I put that in as well, this 37 degrees. Also the 760 kilometres I put in as well for the length of that brown line. Okay, so what we're trying to find here in this diagram is how far directly east did he travel. So if he's gone all the way over here, he's gone a fair way north and he's also gone a fair way east. So you've got to think to yourself, the eastern part is exactly how far from here did he move straight across. This length here is how far east he has gone. So we've got to figure out the length of this line here. So the idea is to convert this into a triangle which uses this length we're trying to find. And because we have this triangle here, we know it's right angled triangle because we want this line here to be perfectly vertical, and we also want the eastern line to be perfectly flat, so it should make a right angle there. You can assume that's 90 degrees. Also, because this is 37 degrees here, this must be 53, because these two have to add up to 90, because that will also make a right angle here. Okay, so now that we've got this triangle, we can use trigonometry to figure out our value of x, how far we went east. So I look at this triangle here, and I think to myself, well, I know that's 53. Obviously, I want to use an angle which is inside my triangle. That's 53. X is my adjacent, and I know my hypotenuse to be 760. So therefore, we're going to use adjacent and hypotenuse, which is cos. So cos of this 53-degree angle is equal to x over 760, and then we get x by itself by multiplying by our 760. And x is equal to this, which equals that to 2 decimal places. So that is exactly how far east he travelled. Even though he travelled 760 kilometres, he only went 457 kilometres directly to the east. He did a whole heap more travelling to the north by the looks of it. But anyway. Okay, so make sure you've got a decent conclusion for these questions as well. Okay, so question B. What is the bearing of Orange from Brisbane? Okay, so we need to be thinking to ourselves with this question. We're going from Orange from Brisbane. What is the bearing? So here, the idea is from Brisbane. Brisbane is our starting position, and we're going from Brisbane to Orange. So we're going from this way to this way. What is the bearing? Well, we know the bearing from Orange to Brisbane. So going from here to here, we know that's 37 degrees. But we want to know the bearing going the other way. So what we think to ourselves, because they are opposite directions, they are separate by 180 degrees. So if one's 37, we can add on 180 and we get the bearing of the other direction. So the bearing of Brisbane to Orange is going to end up being 217. So, yeah. You get one way to think about it, if you look at this diagram, that 217 means that if you set up a northern line here, the angle going from here all the way to Orange, back this way, that's going to be 217 degrees right there. Sorry about the messy diagrams. Okay, so moving on. Question 2. A ship sails from a port for 20 kilometres on a bearing of 140 degrees true, and then turns, really important that he turns here, to travel on a bearing of 230 for 30 kilometres. How far is the ship from the port? Okay, so a lot to take in here. Typically, a lot of people struggle with this, and the reason they struggle is because they have a tough time with these sorts of diagrams. I know it does look like a lot, but we will get there. Okay, so a detailed diagram is essential. So let's give it a shot. Let's see what we've got here. Okay, so start from the beginning. So a ship sails from a port for 20 kilometres. So what I did, I started with my port, I put this dot down, and I literally thought to myself, 20 kilometres on a bearing of 140 degrees true. Well, I think to myself, where exactly is 140 degrees? What sort of bearing does that look like? If I go back to my diagram here, 140 degree bearing is like right here. It's in between south and east. It's almost perfectly southeast, but it's not quite. So we're in this sort of direction. So let's try to make that similar on my diagram. So I started at this point, my port, and I went roughly down here because that's kind of a southeastern direction. I also, from my starting position, wanted to put in a northern line and an eastern line. With true bearings, you always want to use a northern line, but because we're kind of going over to the eastern side, I put in my east line. I could have also put in a southern line if I wanted to as well, but it just gets a little bit messy if you do too many. But north and east were easy to put in. I also used this 140 degrees angle, and I showed that exactly where it needs to be. So it goes from the northern line all the way to my direction. So that is 140 right there. I also put in my eastern line, and because that whole thing is 140, this part here must be just 50, because 90 plus 50 makes my total of 140. So I'm just putting in little bits of information where it's where I can. Okay, so that traveled 20 kilometers down here, and here at this point they turn. It's really important to understand that this is where they turn after this 20 kilometers. They turn on a bearing of 230. Now 230 degrees is over here. It's a southwestern direction. So that's what I try to show here. It's roughly southwest down here. And they do that for 30 kilometers. So I'm writing this stuff in. So I did that line first, and now I'm doing this line. But notice I'm also wanting to put in some of these northern and western directions in, because I'm always wanting to put the northern line in, and we're in the western side here, so I put in the western line as well. Because this bearing is 230, we got to think to ourselves, starting from north and going all the way around, that's 230 degrees. Now, west is 270, so therefore there's an extra 40 in here. So the 230 and the 40 will have to make a total of 270 to get to the western line. So I know that this angle in here is 40. These are the sorts of angles that are going to help you out to figure out your final answer. And then also I put in the length of the ship from the port. So this is this length here. So from boat to port, this is my X. This is what I'm trying to find. Okay, so let's continue on. So we've got to use this diagram somehow to figure out what our X is. So the idea is you want to try and focus on the triangle that you see here. So I got rid of all the extra stuff I put in, and I just focused on the triangle. Obviously, you won't want to do this. You want to keep all this stuff in, but this just makes it hopefully a little bit easier to understand. Okay, so I know this length and I know this length. If I want to find my final length here, I need to know the angle right here, the angle that's paired up with what I want. So, and that's using the cosine rule. So if I can make this pair, I'll be able to figure out what my X is using the cosine rule. Okay, so let's give that a try. How do we figure out this angle here? Well, the idea is you need to be using your bearing information to be able to figure out this angle. So I look at this and I think to myself, how do we figure out this? So, well, I know that this part here is 40 degrees, but if we can figure out this angle in here, we can add these two together. So immediately I'm always looking for alternate angles. So here I'm going to use my eastern line and my western line to make a Z shape. So if that's 50 in there, that means that's 50 in there as well, using the alternate angles. So that's what we need to do. Get that that's 50 and that's 50. And therefore our included angle, this angle in here, is going to be equal to a total of 90, because 50 and 40. So that's actually a right angle, 90 degrees. Okay, so now that we know this angle is 90, we can use the cosine rule to figure it out, because we've got one pair and we know two other side lengths. So using the cosine rule, we set up our formula. Our A and our little a and our A are our pair that we've got here. So we want our a squared changing to an x squared. If that's not happening, then there's a problem, it won't work. And our b and our c are our 20 and our 30. So 20 squared plus 30 squared equals minus 2 times 20 times 30 times cos of 90, our angle. We square root that to get x by itself. And we get that x is equal to the square root of 1,300, which equals that to 2 decimal places. Note this is called the exact answer. It's where they keep it as a cert. And yeah, and then you're done. So try to use this to help you out with some of the similar sort of questions you're going to be seeing. They have a very similar sort of strategy each time, but they are going to be looking different depending on your bearings. So be really careful with your diagrams. Do a really good job of them, and you'll find these a lot easier. Good luck with the questions.